Hello everybody. Today we are going to be going over the Engineering 100 and Robotics 203 CAD lab. To get started, when you open up a CAD computer either on VMware or from one of the CAD computers on North, it should bring up this screen here. What we're going to do is we're going to type in SolidWorks and make sure that we open up the Student Instructional License. Then this tab is going to pop up. It's going to take a while to load, and in the meantime, we will start getting our files ready. First, we will get our folder ready for all of our files. There are a couple different spaces that you can save information on the CAD computers, but my favorite is to go in and type in N and then a colon to bring you to a directory. This can be accessed from any CAD computer or VMware. So let's go in and we're going to create a new folder, and let's title it, say, Engineering 100. And now we can go find our files from Canvas. In Canvas, we are going to go to Files, then we are going to look for Rob Resources, Lab 5 CAD Lab, and we are going to download the entire zip file that includes all the files. This is the starter parts and where we will do most of the assemblies. In your downloads, right-click on that, extract all, and we are going to extract it. This is just how zip files work. Then we can go in, grab all of these files. Here I do a Control-A, Control-C, and just copy them into the folder that we have previously made in our CAD drive. Once we see that SolidWorks is ready, we can click on SolidWorks, press launch, and then wait for it to open. This also could take a few moments. I've skipped ahead here. Don't worry if yours takes longer. First, what we're going to do is we are going to open up our base plate and kind of get a sense for how SolidWorks works. So you can press Open File, look for your directory, Engineering 100, and find that base plate assembly, and press Open. Once it opens up, you can see that we have the full assembly that includes our base plate, wheel, mounts, motors, and the ball caster. First, we will go into some of the basics of how to orient yourself in SolidWorks. So first, you can use the scroll wheel to go in and out, like such. Sometimes it's inverted, and you'll have to decide what you like best. Next is rolling around. If you press down in the center button of your mouse and scroll around, it'll rotate. Next, if you do Control and then the middle button, it will pan around, and you can see here, you can move it on the screen to center it. And lastly is Alt in that middle button, and that will roll it around just slightly. Lastly, if you go up here and select this square, you can set it to automatic orientations just by clicking on the different boxes that you see available. Next, what we will do is we will create a new file. This will be the mount that we are creating and the main part of the creation of the CAD lab. So first what we'll do is we'll go up here and press File, New, and then we will grab that new part and press OK. The first thing we are going to do is mess with some of the document settings. So if you go into SolidWorks, Tools, you can then scroll down until you find Settings, and from there, we will move. In Settings, what we are going to do is we are going to navigate over to Document Properties up on the top, and then we are going to look at these standards. The standard that we want to use is the ANSI standard. So if you see ISO, change it to that. And if that's where it already is, awesome. Next, we will press Accept or just click out of it and get back to our main screen. Now we can get started on construction. First, we are going to navigate over to the Features tab and press Extrude Boss. And then we are going to select the top plane. Next, what we're going to do is we are going to create a rectangle. Don't worry about dimensions yet. We are just going to create a random rectangle, and now we will add dimensions. To add dimensions to our rectangle, what we are going to do is we are going to select Smart Dimension, and then select either of the sides. I will select this slide first and put in our dimension of 12 millimeters. Next, select the other side and put in 72 millimeters. We can see that it automatically scaled it and still fits within all of our bounds. To exit the sketch and actually make it a 3D shape, we are going to select that Exit Sketch. Here we can see that you can pull it up and down depending on how big you want it to be. What we are going to do is we are going to make a blind extrude just by inputting the depth. You can see that by pressing this button, you can flip it around. This flip tool is used in many of the different features. If your hole is in the wrong direction, if you're cut or you're extrude, you just click that and it flips it. To exit this, we will press the green check mark, and now you can see that we have a 3D piece. Next, we will create our second box by doing the same thing. First pressing extrude, and then this time we will press the top of the box that we already have. From here, we will draw a rectangle, making sure to snap it to the bottom and the top lines, but not having it on any of the corners. Next, again, dimension our box properly. And then we will dimension the side. By clicking 2 lines, the Smart Dimension can learn what you want to do it between and correctly place it. Now, again, once we're done, we're going to press that green check mark and exit the sketch. And when we turn it around, you can see the direction it's trying to extrude in. So this one we want to be a little larger. I'm going to pull it up, make sure it's in the correct direction, and then type in our dimension. Press that green check mark, and we are done. Next, we want to cut the triangle out of our piece. So we are going to go over to Extruded Cut, and we are going to select the side of our large box as our plane. What we're going to do is we're going to take the line tool, and we are going to draw the general shape of the triangle, not worrying about dimensions. But as you can see, we are being careful to actually select the different parts of the box that is already there. And then lastly, most importantly, completing our triangle. SolidWorks gets confused if you don't complete all of your shapes, and it will not make the cut properly. So next we can grab our Smart Dimension, dimension that line like we did the others, and then we can press the check mark, exit sketch, and we can see that it will cut through. So right now it's set to a blind cut, and this is fine for our purposes if it is long enough, or you can select through all or up to next. Press that check mark, and as you can see, we are done. Next, we are going to make another cut. So select that extrude cut and select the side again. Now we're going to grab that line tool, again, trace out the general shape, which is almost a triangle, but not quite. Make sure you're not snapped to any unwanted dimensions. As you can see there, it almost snapped to the midpoint, but we want it to be perpendicular. So once we have our full shape, again, we can dimension that last line, make that it's 2 millimeters, and then we are done. You can press that exit sketch button. Now, for this cut, what we want to do is we want to offset it. We do not want it to go through the whole thing. So up in the cut extrude where it says from, we are going to go in and we are going to select offset. Once we select offset, we can set what our distance is. As you can see here, the offset is in the opposite direction. And so once I type in the correct dimension, I'm going to press that reverse button, and now we can see that it is in the correct spot. As we click that, we can see it flipping back and forth. Once we exit out, we are done. We have made our second cut. The next feature we are going to add is the fillet. This is a good way to make things more stable 3D printing or less sharp. So what we're going to do is up here, we're going to navigate to fillet, and then we are going to start selecting the lines that we want to grab. So if you click on all of them, it'll select all of them at the same time, and we can do this in one operation. I like seeing a full preview. It makes it more fun. Make sure you know what you're doing. And then in here, we can type in our dimension. As we can see, the yellow lines show what it will look like when we're done. Press that check mark, and now we have a smoother piece. The next thing we want to do is add our holes. So we are going to rotate down to the bottom, and we're going to make a new sketch on the bottom plane. First thing we're going to do is we are going to grab the point tool and put a single point in the place we want it. After we make our point, we are going to mirror it on the other side. So to start, select that line tool and then select for construction. This will mean that it does not show up or make any cuts. Drag over, find that midpoint, and on the second line, you can find the midpoint there, and just press escape to finish the line. Next, what we are going to do is we are going to select mirror entities. First, entities to mirror, that's our point, and then mirror about, and that is that line. Now that we see we have both points, we can press that check mark, and ta-da! We have made both of our points while only dimensioning one of them. Press exit, and you'll see that this sketch stays on it. That's because this was not a piece that we were adding or removing. Next, we want to turn those into holes. So we're going to click Features, Hole Wizard, and we will see this new tab pulled up. First, we will select the type of hole we want, and so to do this, we will first select the ISO drill types, standard hole up here, and then we need to select our size. So to do that, what we are going to do is scroll down, click that custom sizing, and type in the size we want. Next, we want to make sure that it is what we want, and so we want to turn off that near side countersink. This will ensure that it is a straight hole straight through. We want the hole to go all the way through, so we're going to select up to next, and now we can move to the positions. So first is that you have to select the plane. So we're going to select that bottom plane here, and then we're going to place the two holes on our 2 points. When you press the green check mark, it'll complete the holes, and now if we rotate it, we can see that those holes have successfully gone through in the way we expect them. Next up, we have our final side that we want to cut from. I am going to speed through this because it is features that we have already learned. Once we are done with our piece, we want to go into File, Save As, and then make sure we save it to that same folder that we've been uploading the other pieces to. This will allow us to grab it easier later. It's not strictly necessary, but it certainly does help. Next, we are going to go back into that first assembly and start building our MBOT. So, as we can see, opening it back up, still the only piece in there. The first thing we have to do is add the different pieces for assembly. To do that, we want to navigate over to the Assembly tab, and then click on that Insert Components. So, we're going to go down to Browse and click this first piece, which is the hex stand, and insert it in. Now, we want 4 of these. You can insert it 4 times, or you can go find the piece in the column to the left, and then Control-C, Control-V, Control-V, Control-V. Make sure you don't put them on top of each other. This just makes it easier to see later. Now that we have our pieces, we need to attach them. So we are going to select Mate, and then we are going to start doing things. The mate tool is what allows us to connect pieces and start limiting degrees of freedom. So the first mate we are going to do is we are going to select the circle in the base plate, and then any circle on one of these standoffs. We want to make sure this is a concentric mate. This just makes sure that the circles share the same midpoint. Now you can see that it will rotate on that circle and move up and down, but it is limited to being on that circle. So we need to add a second mate, one between the base plate and the bottom of the standoff. Now it is constricted to stay on the base plate and must be on that circle. So we can see that it rotates but does not move besides that. Now we want to do that 4 more times on the other 4 hex standoffs, and I will speed through this part. The next piece we want to attach is the top plate. So once again, we're going to go to Insert Components, Browse, and find that yellow top plate. Open that up, insert it into the assembly anywhere, and now we are going to put in the mates for this piece. So because we have a lot of it already there, we don't need to do as many. We're going to start by making that concentric circle between the plate and one of the standoffs. Now, to connect it fully, we really only need 2, so I'm going to go to the opposite corner and make a concentric mate here as well. We can see now that it is constrained fully and cannot rotate, but it still can move up and down because we have not constrained that movement. So, top of the standoff, bottom of the plate, and it is now fully attached. It cannot be moved around. Next, we want to attach the screws. These are not a part of the files we have, and these will be built in straight from SolidWorks. So what we're going to do is navigate over here to the Design Library, which is this little bookshelf, and find some components built in. We are going to go to the toolbox. Then we are going to make sure that we select the ANSI inch, bolts and screws, and then we want to find machine screws. As you can see, there's a couple different options. The one we are going to be using is the pan crosshead. So you can go drag that and drag it all the way out. So obviously right now it is not the correct piece, and so we are going to go into the settings and make sure that its size and properties are what we expect them to be. Now, for me, it let me select and place all 8 bolts that I needed immediately. If this is not the case for you, you can do what we did earlier with the standoffs. Go into the components, Control-C, Control-V, and make sure that you have all 8. Next, we have to mate the screws. Similar to the hex standoffs, we will need to do 2 constraints for them. The first one is the concentric. Oh, we'll see here that it flipped upside down, so you can always press that flip button and make sure that it's the correct orientation. And then the second mate we need to make is that coincident to the top. So select the bottom of that screw, top of that plate, and ta-da. We need to do this 7 more times for each screw, and I will speed through this part as well. And now we have a complete MBOT, and our last step is just to add that servo mount that we have just created. So to do that, what we are going to do is we are going to once again go over to Insert Components, And if you still have it open, it should pop up right there, or you can go into Browse. So click in the window and then to drop that, and now we can start attaching it. Once again, we are going to select that mate, select the bottom of that, top the top plate, and make sure that's the correct way up. Yes. And next we are going to do a concentric mate to one of the holes and one of the holes that we plan on mating it to. Now, our last mate is a little tricky. What we're going to do is we're going to select that hole and the correct hole, and it won't automatically snap. But we want to make sure that we press that coincident or concentric, and then it'll pop up this here. What we want to do is we want to create this mate using misalignment. You'll see it switches over, and now there are a few misalignment options. I like doing symmetrical, but it is up to you. These misalignments are due to just very, very tiny distances that do not perfectly match up, but they are not actually a problem for our purposes. Realistically, those screws will fit through, and so using this misaligned mate is perfect. Once you have done that, you will see that you are completely finished. You have now completed the CAD lab and have a complete MBOT with your very own servo mount. Make sure to look at all of the deliverables that are due on Canvas and make sure everything is saved. Thank you all for listening, and I hope this was a good way to learn.